Hello again, everybody. Today is a little bit more about Java. Um, there will be a little bit of history of how framework, how Wix moved across different Java versions. Over the past almost 5 years, we've upgraded Java already 3 times. We had 3 iterations. And what was interesting is that with each iteration, we're able to reduce the time to upgrade more and more and more. So in this talk today, I will try to stress what were the principles, what were the changes in our process that we did to allow us to improve the velocity. Now, you may not be involved in Java, or you may not be concerned with Java upgrades on a daily basis, so it might be not that interesting. But what I would like you to take away is the principles, the ideas to move forward with your own upgrades. I think most of you, in one way or the other, are doing some kind of migrations, library upgrades, or other similar endeavors. So who is that we that I've mentioned? We are the framework team, part of Nile Group. We are 5 talented developers and me, team lead. Our main concern is about dealing with framework maintenance, framework features, basically work on framework on the things that are really important to backend developers. And one of the well, actually 2 things that are not directly related to framework are library upgrades that we're dealing with. And Java is not a library, but it's another big piece that we're dealing with. So a bit of a step back in history. It's 2020. Java 11 has been released 2 years ago, and we're still stuck on Java 8, which is at that time was already 6 years old. I was a developer in Scala framework in those days, and then my manager, Vilus, comes to me and says, okay, how about you upgrade Java for us? I said, oh, it's not a big deal, it's just probably that easy, right? Boy, I was wrong. But what does it take to upgrade Java, right? There are 3 main components that we need to deal with. So first of all, it's JDK. It's a toolchain that takes source code, compiles it, and then generates a bytecode. Bytecode is a language that runtime understands and runs in production. So 3 things: toolchain, bytecode, and runtime. All good. That's kind of simple, right? Just 3 things to do, that's fine. No. As usual, the complication is scale in Wix. So we have 58 repositories that houses 15 million lines of code, give or take, depends on how you calculate. There are at least 2,500 JVM services that we have, at least last time I checked. And there's always something lurking behind the corner. Whenever we do something, something happens. Something is really interesting, and we need to take care of it. So it all starts looking like like one big rock, one big item that we have to somehow move forward. Whenever we touch, it's really heavy and does not let us move. So what can we do about it? Naturally, the approach would be to split. If you remember in the beginning, I mentioned that there are 3 components to upgrade, and that's where we decided that would be a good start to split. So what should go first? Naturally, bytecode must go last because, well, JDK toolchain or OpenJDK generates bytecode, so it cannot be the first one. JVM needs to understand the bytecode. It also has to go before the bytecode, so it goes the last. Toolchain, JDK, runs the tests. And we cannot put anything in production without testing it first, right? So it's, of course, the first step we want to do. Finally, it remains JVM. So we have 3 steps: OpenJDK, JVM, and upgrade the bytecode. And the best part is that at that time, 2020, Bazel supported it out of the box. It was very easy. Like you just go to one file, modify this, modify that, and then you're done. So we have 3 steps. We can move forward, right? It's easy. Well, there was something missing about that. It's 3 steps, but these are 3 large steps. If you remind, it's horizontal cuts. So if we change something for 2,500 services, it would impact all of them at once. We had a hunch that it's not enough. We have to do something about it. And some of the reasons were, first of all, is in the beginning when we did a dry run on JDK upgrade, we found that there are many services, a lot of code that's breaking. And to fix all that code took time. If we fix something in one place, then go to the next place, then we didn't want, like the code is alive, right? So, and if we fix, and then somebody introduces a new code that's breaking what was already fixed. So we didn't want to go into this game of like whack-a-mole as fun as it sounds. So that was the first problem of the, this whole big upgrade all at once. The second part was blockers. We had a hunch that there will be a code that is hard to migrate. It could be a big library that needs to be upgraded for new Java version, or there could be some code that has to be rewritten that's really out of our control. So some things are bound to take time. Retrospectively, that's what happened. We found quite a few these persistent places where we yeah, Rotem knows about it. These persistent places where we got stuck. So that's another point. Rollbacks. The first rule of production, if something fails, you have to roll back, right? Imagine if we upgrade JVM for 2,500 services, and there's a production issue. We have to roll back. What does it mean? We have to roll back all 2,500. That's not cool. That's a lot of noise. That's a lot of problems for developers. So yeah, 3 steps was too optimistic. We need to find out a way to split it in more steps. Of course, those 2,500 services is much too fine-grained step. Like it would take us forever to go all over them one by one. The hint was repositories. We had 58 repositories. So let's see if that can be done. Luckily enough, for us, Bazel team helped out us a lot. We were able to find a way to upgrade Java, JDK, bytecode, everything per repository. And the reason for that was that each repository is a workspace. And for the workspace, we can have an individual definition of toolchain. So let's say we have here Wix Framework repository. For Wix Framework, this is like, it's an actual pull request. For Wix Framework, we can define, let's say, JDK 21, but it generates bytecode for 17, and runtime is 17 as well. So we were able to split the work into each repository. How would it look like in real life? Like, what's the process that we got? Let's imagine 2 repositories that are, well, imagine repositories, they are repository 1 and 2. Let's call it this way. At the beginning, it's all on 17. We check on repository 1, everything is fine, it builds. We upgrade the JDK to 21. Give it a few days for dust to settle, people people test, and all things happening. We decide to upgrade JVM, it's still all good. A few weeks, a few days, upgrade the bytecode, still okay, moving forward. Repository 2, again, the same drill, check, upgrade JDK, all fine. A few days, upgrade JVM, hopefully fine, but no. Production issue. Although, even though tests are passing, even though everything seemed fine in tests, but of course production is a little bit unique maybe, so we have production issue. We immediately roll back to 17. And you see, the repository 1 is not impacted. It's still upgraded, it still remains, people cannot introduce any breaking changes. So we roll back to 17, we problem solve together with the owners, and keep upgrading to 21, and so on and so forth. And we are done with both repositories. So the problem in repository 2 did not really block us, which is great. We have 150 incremental steps. They are small, they are independent of each other. We move forward, we can take one step at a time, or 10 steps at a time. And in fact, in the later stages, we actually did take like 10 repositories and upgrade all of them to let's say 21, and so on and so forth. So we have lots of steps. We're moving forward. It's all good. We're done, right? Not so fast. We have our process. We first of all upgrade JDK, JVM, and then bytecode. And what happened here is that for whatever reason, regardless of our process, the bytecode of the service did not match the bytecode of the JVM, even though we followed the process. What happened here, particularly in this case, it was a custom Docker image build. This particular service had its own Java version defined in its Docker image. It's a custom Docker image. It did not follow our process, unfortunately. We didn't even notice that there is this problem here. And over the multiple iterations, 3 upgrades, we found there are many more of these. There were many more different, special deployments. The custom Docker image is probably the lighter one. People define their custom Docker images for different reasons. It could be because they have special requirements for libraries or whatnot. There are like different interesting reasoning. There are unique runtimes. Yes, we had some Google App Engine issues. We had var artifacts, web archive artifacts that required special treatment. Vespa services have their own runtime. The biggest one is, of course, PCI environment. It's outside of the mainstream. PCI stands for payments in card industry. In all of those cases, framework themselves, ourselves, we could not really deal with that. We had to go and ask for help from different teams. So specifically for PCI environment, it was probably the biggest hurdle. We went out and asked if they help to upgrade. The problem there was that in the beginning, back in 2020, PCI environment was structured such a way that there were multiple virtual machines. Each virtual machine is running multiple services. And each virtual machine had its own Java version, its own runtime. So if you want to upgrade Java runtime on, let's say, virtual machine 1, you would impact multiple services. And if you impact multiple services, we have a problem. We have a problem because if there's a problem, we have to roll back, and again, many services get impacted. So what the PCI team did was, we tried to upgrade it. It failed many times. So the solution was to take each service and put it in its own virtual machine. Each virtual machine has its own Java version, and then for each virtual machine, we can upgrade Java individually and move forwards one by one. It was kind of cool. It worked fine, but there was one problem. Okay, it should be red there. There was one problem that several developers, if they want to upgrade Java for their service, they have to coordinate with the PCI team. They're a friendly bunch, but still you have to be in sync all the time. There were complications. The solution was, of course, to Dockerize everything. We we've defined a Docker base image for each PCI service. And each PCI service would take that base image and deploy their stuff into the production. So then this created an independent flow between PCI team and the PCI services. They could deploy on their own volition. As we moved forward, we found that we keep modifying Docker images over and over again for different reasons. It's a new version, different parameters, different settings and everything. And we found that the feedback that we get from base image modification is too late. Back in 2020, and it was like for, I don't know, probably 2 years ago, the Docker image, Docker base image build was very asynchronous. The feedback was very slow. Imagine a situation where we update the Docker file that contains Docker image definition. It goes to Team City builds it, maybe it succeeds, maybe it fails. If it succeeds, we get a digest of the image that we put again in GitHub, then Bazel builds it, fails or succeeds, and finally we GA into production with the final image. Fail or succeed, yeah. So sometimes this asynchronous flow took us a day or two until we actually got into the situation where we are happy with the change. What we did to fix this was to move everything into Bazel system, into Bazel build files. All of the instructions to build the base image are defined now in the build Bazel files. To give us more feedback, we also defined a test application and tests to actually run everything in CI to see if it fails or succeeds. As a result, we get the feedback immediately within the PR. We get test results, and since the tests are running actual test application, actual base image, we are very confident that it will succeed in production. So we did all that, and what did we achieve? What's the outcome? What does it look like? So back in 2020, we started off with Java 8. That was really old. Our first upgrade took us over 2 years with all of the moving parts and everything. Java 17 took us approximately 9 months to upgrade. And finally, Java 21 was just 4 months to upgrade. And hopefully Java 25, maybe next year, we will can do it even faster. Let's see. So what you could take away on your next migration? What principles you could use? First of all, it's very important to get a buy-in from organization. Most likely, if you do a migration, you will need some help from other teams. We did ask help from PCI team, Ecom, Premium, many teams really got involved into this whole ordeal. If possible, it's not always possible, but it's important to split the work into small and independent steps. If you have independent steps, nothing will block you. And if it's a big project, big migration, like that big rock you may remember, then it will help you morally not to lose hope that I will ever complete this. Like if it's step by step, I can see the progress all the time. Early feedback. I do some changes, I want to see the feedback, I want to fix myself. If it takes a lot of time to get feedback on your changes, then it's a bit of a problem. Things will be slower for you. And in fact, this early feedback is something that we employ in Nile. Like in Nile, as early feedback as possible is a good thing. While doing the migration or any kind of upgrade, you will most likely encounter some technical debt that remains from the past. In Java migration, we encountered a lot of migrations that were not completely done. There was fragmentation in the ecosystem. Those different runtimes was problematic We tried to fix them. We made it more uniform, and this allowed us to move faster in future. Also, if you start your own migration, don't drop it at like 95%. Like that 5% will be a debt that somebody else will have to pay, or you yourself will have to pay in the future. Finally, be prepared for unknowns. It's always something behind the corner. Thank you.